Roll 'em.
Hello, my name's Adam. This would be Steven and Madison, or my fellow VEX robotics team members. And this year we have built a robot, shockingly, for VEX. This is a VEX robot. It's designed to compete in a series of competitions known as the VEX Robotics Competitions. Shockingly, it's basically an 18-inch cube is the size it fits into. And this year it's designed to be able to score very large game objects. One's up to an 18-inch, basically a beach ball. The other one's a 6 or 8-inch geometric object that this thing carries. The goal of this game is to basically be able just to move these objects from one side of the field to the other. The challenge is that there is a 2-inch high bump in the middle of the field, and for additional points, we can do a high-reaching goal where the robot reaches to a height of almost 24 inches and deposits the smaller game object into that. The VEX competition goes on yearly. Every year we build a different design robot for that, and that takes money. This year's robot is probably one of our most advanced we've ever built. You can see remains of last year's robot over here. And I say remains, because that's all that is left of it. So last year's robot was a special type of design. It was an omnidirectional robot, so the robot could go forwards and backwards, and it could turn around in circles. But it can also go sideways, which means it's very, very maneuverable in the field.
So what's the difference between this and like an RC car that you just buy at the store? I mean,
so this robot has been entirely designed, built, constructed, machined, and programmed by this team. We use the Robot C programming language, which is a stem off the C programming language. It gives us capability to do all sorts of things, from basic control to the robot to programming an autonomous period where the robot must drive itself for 30 seconds. You can need to do this two ways. One, you can do it pre-timed, so you tell the robot, I want you to move forward for 5 seconds, turn right, move forward for another 5 seconds. Or you can just, the robot makes all the decisions on itself, so it's a truly autonomous robot. To do that, we use sensors. We have infrared sensors, line followers, touch sensors, all sorts of different things we can use to make this robot drive itself. Doing something like that gives us a huge potential to get a programming award. Something we're really hoping to do.
so what would be helpful to make your robotics team even better?
So we're always looking for new members. If you guys want to stop by, just Google Lakewood Clubhouse. You'll come with the Clubhouse website, and there'll be more information there. The second thing that can help us definitely is funding. VEX Robotics is unfortunately not very cheap. We have to use all VEX regulation parts, and they aren't the cheapest thing. I mean, every year we have to cut new metal, buy new motors that break, replace broken parts, things like that, and that costs the team a lot of money. If we don't get this, we can't compete. Like, this year's robot never got to compete because we received funding too late and weren't able to get parts built in time. We're always also looking for sponsorship, so if a local business would like to have their name put on a robot and put it on our t-shirt, we'd be happy to do that. Now you... Up.
I'm trying.
Retract.
Now up. Run.